right, so now let's add vectors algebraically. So once again, summing up from your part 3 video that you just finished, this part is only going to deal with quote-unquote day 1, day 2 triangles. Once again, in this problem, this hiker decides to walk this way, and then on day 2 they walk that way. So what if they really had only done this? Solve for what if they would have only done this. So the template that we are going to use, and I'm just going to insert a new slide real quick for you guys. This is not in your packet, I'm just going to make it real quick. This is kind of like the plan of attack. First thing you want to do is you want to obviously write down your givens and stuff. I'm going to skip that. You should know that by now. Okay, so you're going to draw the day 1 triangle, labeling x1, y1, and resultant, and theta. And then you're going to solve for x1 and y1 by doing your resolving vector stuff. Okay, so that's done. Then you're going to draw day 2 triangle, and you're going to solve for x2 and y2, and then you're going to solve for x total and y total. Once you do that, now you're going to draw your resultant, the what if I would have only moved this way triangle. And you're going to calculate resultant magnitude by using Pythagorean theorem. And then you're going to calculate resultant direction by using inverse tan of opposite over adjacent. And I want to write it that way because remember, it'll be y over x if the ultimate triangle. It'll be y over x if the ultimate triangle is a bow tie, and it'll be x over y if the ultimate triangle is an hourglass. So I don't know yet. We got to keep it very, very plain Jane right there. Okay, one little side note that I want to bring in here is that if your theta, like you're given a problem, an object moves due east, an object moves due south, due west, well, do you still have to solve for x and y because it's only utilizing one axis? Technically, that's your result that they gave you. So you are utilizing both axes, and by that then, you should treat them as bow tie triangles. So if theta equals 0, 90, 180, 270, or 360, you're going to treat that triangle as a bow tie. So that would be y over x, right? That would be a y over x for the inverse tan stuff there. Okay, also, when you draw your resultant triangle, your first vector drawn is like same direction as first vector drawn in day 1 triangle. So like, okay, I solved for my x total, I solved for my y total. Which one do you want me to write first? Should I go north first? Should I go east first? Well, look at day 1's triangle. In order to make that resultant line, which vector did you have to draw first? Did you have to go east first? If so, then you would do your x total first. Did you have to move north first? Well, if so, then do your y total first. So here's like a summing it up of what you're about to do for this problem. Let's move through this together, guys. Okay, so this problem says a hiker walks 27.0 kilometers from the base camp. So I'm going to call this x1, 27.0 kilometers, and theta 1 equals 35 degrees south of east. The next day, so x2, is 41.0 kilometers, and that theta 2 is 65 degrees north of east. calculate the magnitude and direction of the resultant. So x sub r equals, I don't know, kilometers, and theta equals, I don't know, degrees, something of something, right? It's either going to be north of east, south of west, east of south, or east of north. We'll figure that out from there. Okay, so let's do our day one stuff. The first thing that you want to do is draw out your day one triangle. So here's our resultant, and we know that we had to go south of east. So you went south of your eastern line. So to draw that out, that means that you moved east, and then you moved south, right? South of east, drawing your resultant, theta 1, and this would be x1. So you want to, sorry guys, x1r, theta 2r. So this is x1r. Solve for x1, solve for y1. Now what I like to put right here is, that's going to be positive, that's going to be negative when I calculate this bad boy out. Okay, now, with that in mind, to solve for x1, you need to ask yourself, is this an hourglass or a bow tie triangle? So that I know that if I want to do cosine theta or do I want to do sine theta? Well, look at this guy. You're moving adjacent right there, so that should be x1 is cosine theta times x1r. So that would be the cosine of 35 times 27.0. So put that in your calculator. Cosine of 35 times 27.0. All right, so that should give you roughly about 22. So your x1 is 22 kilometers. That's not a final answer, but it's pretty darn important, so let's start it. Y1 is going to be sine theta times x1r, where that would be the sine of 35 times 27.0. Throw that in your calculator. That one should come out to be 15, but check it out, you're moving south, so your y1 is really a negative 15 kilometers. Once again, it's not a final answer, but we could definitely star that guy. Okay, let's look at day 2 data. Day 2 here then is you went north of your eastern line. So you went east and then north. So you went north of your eastern line. Throw in your theta, throw in your x2r, solve for x2, which is going to be positive, solve for y2, which is going to be positive. This once again is an example of a bow tie triangle. So x2 is cosine theta times your resultant, x2r, whereas cosine of 65 times 41.0. Okay, please put that in your calculator. Cosine 65 times 41.0 gives us 17. So x2, although it's not final, still started, is 17 kilometers. Y2 is going to be sine theta times x2r, your resultant. So therefore, that would be the sine of 65 times 41.0. Throw that into your calculators. Sine 65 times 41.0 gives you about 37. So therefore, y sub 2 equals 37 kilometers. All right, so we solved for x1, y1. We solved for x2, y2. Now the next thing that we want to do is get our total into here. So x total is going to equal, this is number 30. So then x total is going to equal x1 plus x2. And whereas your x1 quantity came out to be 22 and your x2 is 17, that comes out to be 39. So x total, although not final, still start, is 39 kilometers. Y total is going to be y1 plus y2. And looking back, we have a negative 15 and a positive 37. That would give you 22. So y total equals 22 kilometers. Not final, but still start because it's pretty darn important. Okay, so now we can actually get into number 4, drawing the actual triangle. Well, okay, do I want to go x total first or do I want to go y total first? Let's look back at the first triangle that you drew. In order to draw south of east, guys, okay, that's the first triangle. In order to draw south of east, did you have to go south first or did you have to go east first? In other words, did you have to do a y component first or an x component first? Check it out. Look at your day one triangle here, okay? Assess this day one triangle. What did you have to do first? In order to get that resultant line, you had to travel x total first. So we want to go over 39, and we want to go up 22, because they're positive, right? So there's our theta that we're ultimately trying to solve for. There's our xr that we're ultimately trying to solve for. Here's x total, here's y total. So to solve for the magnitude then, that's going to be the square root of x total squared plus y total squared equals, I'm going to call it x of r. Okay, square root of 39 squared plus 22 squared equals. Please put that in your calculator. 39 squared plus 22 equals square root second answer equals. Or square root, start your parenthesis, 39 squared plus 22 squared, end your parenthesis equals. Either way. Calculator answer, calculator answer. Okay, you should have about 45 on your calculator. We want to sig fig, so 45 kilometers is how far this hiker could have gone if she just did it in one direct swoop. Okay, let's solve for theta now. Okay, assessing your new triangle, your number 4 triangle. Is this an hourglass or a bow tie? Okay, so this last step here, determine if it's an hourglass or a bow tie, and this one is a bow tie triangle. So with that in mind, that means that the inverse tan is going to be y total, opposite, over x total, adjacent. Therefore, we have the inverse tan of 22 divided by 39. Please put that in your calculator. Inverse tan, parentheses, 22 divided by 39, end parentheses equals. Can't stress it enough, guys. You have to be in degrees and not radians at this time. That should give you 29 degrees. And then really your final answer then is 29 degrees. Look at your real triangle. How did you move? Did you move north of your eastern line or did you move east of your northern line? You went north of east. Box it. Yay! Okay, so these are big problems. They take a minute. They definitely will, but my lord, get this, the setup down, those 6 steps, and you should be A-okay. A-okay. Take your time. At this time, you should be able to successfully complete your finding resultant worksheet. Good luck. Please see me if you have questions, guys.